This is Algebra 1, Term 4, Lesson 3, Graphing Quadratics. We'll begin with a quick activity in graspable math, and then we'll go to Desmos Classroom and do a lengthy activity, graphing quadratic equations, and then finally we'll end up with a quick card sort and a couple more questions in our slides. So let's take a look at the graspable math. This is your graspable math quadratic function activity, and all but one of these are very similar. So let's take a look. When you go into the activity, they'll have one button to press, and when they do, it produces another graph, and then they're going to slide this up or down. So they'll grab it and slide it. As soon as it matches the graph, it will turn bright green. This button will pop up and say bright green, and they will be finished, so they'll be able to continue. All of these are the same, but the button's going to look different for some of these. So this one says x squared plus a. This one says a times x squared plus b. So we're trying to get an intuitive feel for what these numbers are doing to the graph. They should already know a lot about this because we have transformed lines and we have transformed absolute value functions. And of course, the standard works for all types of functions. If you multiply a function by a number, it makes it steeper. If you add a number to the x, it moves left, right. If you add a number to y, it moves up, down. So they're just practicing and hopefully learning it, but if not, that's okay, because we're about to do another activity where they can't just kind of guess. They really do need to know. Now the last question is going to ask them a question to see if they've learned it. So this will kind of give you a heads up before you head over to your Desmos. Are they getting this, or are they just playing until they figure it out? And you'll have both. You'll have some kids that totally understand what it's doing, and then you'll have some that are just basically guessing until they get it right. Let's go ahead and take a look at our Desmos activity. This is called Quadratics, Graphs, and Equations. It says 45 to 60 minutes. I would say 60 minutes is probably right. I did take off some of the questions here. I think this was initially for an Algebra 2 class maybe. I'm not sure, but it had several challenging exercises at the end, and since we are just kind of getting started, I did take off a few, but they still have some challenging ones left in here. So there are 12 slides, or 12 screens. So let's start with the first one. So here they're introduced to some new vocabulary. The x-intercepts of the graph of a function are also called zeros. So number one, why do you think they're called zeros? So let's let them think about why that might be. Give them plenty of time to figure it out for themselves, and if they can't figure it out eventually, you will of course go over that with them, because we do want them to know the vocabulary and what it means. And then what are the zeros for this function? So they will pick that off of their graph. Now they have the parent function. They're simply going to type the equation into the blank. It is given in the directions, so this is simply reviewing the fact that this is the quadratic parent function. If you want, you could even do your quick algebra aerobics again and go through the 5 parents for this course. This would be a good time to just have a brain break and do that if they've forgotten those. And now is where it gets started. So we're going to transform this graph, and I would definitely not give them any help at first. Give them a lot of time to kind of play with this and see if they can remember how to make these parabolas translate left, right, up, and down. If you're seeing a group is just not getting anywhere near doing it, but maybe another one is, you perhaps could share out some of the student work to get kids going. The key is to have those parentheses in there for the horizontal translations, and some may not remember that, so they may have trouble with the purple one and the green one, but hopefully all of them can do the blue one and the orange one. If you have any students that are colorblind in your class, and I had that unfortunately, they will definitely need to be paired up with a student who is not colorblind, so they can help point out where these points are so that they can do the activity. All right, this one is kind of getting them to think. So if your students were struggling on that last screen with your horizontal translations. This is going to hopefully get them going on that. If you do see them struggling, one other option you have is just to open this slide and let them see it. Maybe paste them up to screen 3 and then open 4 when you see some kids are struggling. Say, take a look at 4 and let's see if you can come back and use something there to help you maybe come up with some ideas. On this one, all of these parabolas are to go through 0, 0, the origin. So you may want to make sure they're paying attention to the vertex of this graph. So all of them have to pass through the origin. So the question is, does it have to be the vertex? You could ask that question. That would be a great conversation to have. What I've discovered on this activity, though, is they are lost in their world of working, and pretty much most of your conversations with them are going to be ignored, especially if they're not done, because they're furiously trying things. So you may want to just lay off the conversations and see what they can do. This is a true inquiry task, start to finish. It really is. So you can't really stop to have these deep conversations because they don't want to stop, and they may not hear anything that's being discussed. So but if you do see a kid way over, he's got parabolas left to right and they're not centered on the y-axis, you may want to come over and help them reread those directions in case they missed this little origin. I bolded that because I did have kids that were struggling to get. They were making parabolas just go through the 2 points and ignoring the vertex or ignoring the origin. All right, so here we have 3 points that are not symmetric, so this gets interesting. This one may pose a challenge until they kind of really get the concept of the vertex form and where that vertex appears in the equation. They may have to come back to this one, so let them play with it. Don't say too much, but they may want to come over here and look at one of these. They went left and right, they went up and down. My goodness, what are we doing here? The vertex is over here and it's down. So let them play with that for a while, but let's keep going. Now, when they get to screen number 7, we're doing something completely different. They are not using the vertex anymore, but they are using the zeros. So it says here that all these equations need to intersect the zeros, -4 and +3. And right now none of them do. So they'll all need to be changed. They all do intersect the same zeros though to start. So that might be something they'll notice. But again, let them play. Everything in this lesson they are going to hear again and again and again. So don't panic if some of your students struggle through this first piece. It's actually kind of common for some of them not to see things at first, and give them peace of mind. Say it's okay. I mean, the whole point is just to see what you notice, and we're going to get you there, so don't worry. From my experience though, when I sat my kids in my teams, I almost always had at least one in a team that would notice something that they would then share with the rest of their teammates. And so that is a real good way for kids that are struggling to keep discovering and seeing things and not get too frustrated. All right, now we are really getting into some translations, but they're all kind of similar because they're all really close to the x-axis. Some of these are opening up and some of these are opening down. So let's see if we can remember how to make them open down. And then here it says graph 5 parabolas that have the same x-intercept. So all of them have to go through -4 and 4, but they have different vertices. And each vertex is also a y-intercept. So these are the 4 vertices that are here. I think I'm missing one. Let's see, I need a purple one. Oh, there it is. There's the purple one. Orange, green, blue, and red. Again, if you have kids that are colorblind, they absolutely will need some help. You could even put the order pairs on the board for each of those points and label them with their color, and that would assist your colorblind students. Hopefully you don't have a lot of kids like that, but I think every year it seems like I have at least one now, which is interesting. Now they have several equations to choose from, but only one works, and which one works. So, if they're struggling on those other ones, having them move forward and then come back is a good strategy in this assignment, because maybe they're just not getting that they do need factors in their equation like this. If they see this equation, then they may realize, oh, I could try that, and then they can go back. And they will do that, and that's what we want. We want them to see this form and realize that's a good strategy. Let me go back. Here's one. This is where it gets a little tricky. I would say on screens 11 and 12, you might want to treat these like bonus. Because again, they're not given points that are symmetric. They're not given the vertex. And you could even talk here, and maybe you could get everybody on this slide and talk about the fact that we don't have the vertex, and how do you know you don't have the vertex? That would be something to talk about. Symmetry is important. If we have the vertex, we'll be able to see that symmetry in the graph, and we can't really see it here. And then here's one. This one's even more interesting. It has no x-intercepts. Not that important at this point, but we're giving them just kind of drinking out of a fire hose today and getting all the different things that are connected here in these quadratic graphs. So now that we're done with this activity, let's move on to the last part, which is in our slides. So this is the first slide they'll do, and it's graphing a quadratic. So they would just type this into Desmos, fill out this table, and then I'm asking them to find the rates of change between consecutive points. Now we did this in the last assignment, so hopefully they will automatically think, oh, I need to see how far apart these slopes are, because that's kind of where that's where I want them to go, is, notice the slopes that are in your table. And what do you notice about them? Are they increasing? Are they decreasing? Are they increasing at a constant rate? Are they decreasing at a constant rate? I will give you some pointers in your teacher show notes for your teacher slides about this task. But they should notice these are equally spaced. That's kind of the point of this task. They will insert a graph of this function on the screen. The second one is similar, but notice this time we have a coefficient of 2. So this will be twice as steep, and that's kind of important. That's a key word here. And when they do their rates of change, they should notice that that might have something to do with the difference in these rates of change compared to the last quadratic. And then finally, we got one that's going the other direction. So this time we have a quadratic equation that has a coefficient of -3. And so the question is, how is that going to affect these slopes? So they'll get their values for y, and then they'll get the slopes in that table, and then they'll look at those rates of change and see what they're doing. And they'll type something. I do have guiding questions in their notes, so let's take a look at those. So the first one is just going to ask them, how are these slopes changing? Then I'm going to say, how are these rates of change different? So notice this one multiplied by 2. It may impact the rates of change that they're seeing in this little blue table. And what part of the equation reveals this difference that you're seeing? And then the last one, what's going on with these differences? If you subtract these y coordinates, or if you get the differences here, you put it here. But if you get the differences in your slopes, what's going on? And how do you see that in your equation? And then our last task is a card sort. These are very simple questions. I would say this is not going to take long at all, because most of these cards are very basic transformations, horizontal and vertical. There's literally only one card where they have to stretch vertically, or it has a factor of 2 on it. So let's take a look at the card sort, and I'll show you. You don't really have to do much to assign this. You will print out these cards. Here they are. They're already mixed up, so each equation should be paired with one description, one vertex, and one graph. And these are not matched up. So if you're thinking, oh, these are messed up, no, they're not. This is a description for some other equation. So they will match up this equation with one description and one card. There are 2 pages. Do not print these back to back, because they do need to cut these out, and it'll just be a disaster if you print them back to back. So this is not like that card stack the other day. This is just a basic sort assignment. Each team just does one sort, and that way you don't have so many. You could check them just by coming around and looking at them. Or you could just not check them. I mean, it's up to you. I usually don't when there's this many. I just let the kids do it and see. To record their work, I simply ask them to insert pictures. Maybe lay them out flat on their table and then take a picture and just insert it in their slides. And all the kids can insert that. Now at the bottom of this slide, I do have a couple of questions for them to answer. How can you determine if a graph is being translated left or right by using the equation? And how can you determine if the graph is translated up or down by using the equation? Now, this activity is significantly simpler than all the rest. So, if you're doing your Desmos activity and you are noticing a significant number of kids are not making progress, they are just not seeing it, it may be wise to take a break to do this card sort and then come back. I have this assignment scheduled for 2 to 3 days. And honestly, it may take 2 to 3 days, especially on some of those more challenging ones. And if you plan to do all 12, you probably will need longer because they do need to have time to really think about it. And we need to encourage them not to give up so quickly, especially when they're learning a new concept. It's okay to not know something the first second you see it. So give it some time and then break it up with this card sort if needed to help them make sense of it. Another thing you could do is if you're taking a break, they could come do their slides. And as they do this graph, they could talk about how does this equation show you something about this graph and have them discuss it here. It's not part of this slide, but it would be a way to go over that and see how they're doing. Maybe have teams come up. Can you come explain to me what this +1 is telling you about this graph? Can you explain to me what this 2 here in front of the parentheses is telling you about this graph? And then the same thing here. What is this +1 telling you? What is this -3 coefficient telling you? So you could have those conversations and then go back into your Desmos activity again. So feel free to break that up however you need to. But it is challenging. The Desmos is significantly harder than either of these parts inside of your slides. So this concludes graphing quadratics. Next time, we're going to do some applications using quadratic functions. Y'all have a great day.